So I'll talk briefly about the exposure time calculators. They're accessible through this. So essentially, if you go to prima-ipac-caltech.edu, then the page itself will be quite obvious in directing you to the ETC. As you will see, they are rather simple, and there's two objectives there. First, it's because we're early in the process of designing and defining the instrument. So it wouldn't be useful to make them more complicated or closer to what we currently think the instruments work. Uh, Rather, we're giving you guidelines that provide you a way to estimate the time you need in a sort of global way to reach a notion of feasibility of your program. Obviously, they will evolve as the instrument evolves. They will get more complex and identify more situations that you will have to go through. But at this time, we'd rather keep them simple. And the other reason why they are kept simple is so as not to stifle your creativity. Right now, what we're trying to do is engage you in the science that can be done with Prima, and therefore putting up a too complex ETC would probably deter people that would like to get on board. So I will just go through the different panels, which are not many of the ETC, to show you essentially a decision tree for this. So first thing, it looks like this. This is the entrance page, and the first thing you need to do is select the instrument. The ETC is built instrument by instrument, and it reflects the fact that the instruments don't work together. They will necessarily work in sequence. So you have to choose whether you're using Virus or Primager, and depending on what you have selected, you have two different pages that will open for you, allowing you to precise the kind of observation that you want to do. So let's start with Virus. So you just click on Virus here, and this brings you to the main page of the Virus time estimator. At this moment, what we are proposing is 3 observing modes for Virus: the low resolution point source, so there's only a single target; the low resolution map, where there's not only targets but there's an area; and the high resolution point source. Later on, there will be a high resolution map, but it's not yet implemented. So you select the one that you want. There are always text boxes that we encourage you to read at least once to try and figure out the limits of the estimation. So once you have selected a mode, the input will appear for that specific mode. So typically for low resolution point source, you need to provide the line flux that you expect to reach at 5 sigma. And the calculate will give you an observing time. There are some warnings that may appear, such as here. You selected a very bright source for Virus, and so your observing time is dominated by overhead. So that means that probably it's not the optimal way of making that observation. Or you could be making it in high resolution and get more information for not much more time. In low resolution mapping mode, you'll see that you have a new box, which is essentially the area that you want to measure. There can be survey depth, there can be continuum flux density, minimum detectable flux. So these are typically elements that you will need to input depending on the kind of observation that you make. And in high resolution mode, again you need a reference wavelength for the time estimator to be able to provide a computation, the continuum flux density and the minimum detectable line flux that you want to observe on this spectrum. As I said, high resolution mapping is possible, but it's not currently supported in the ETC. It will come later, I think. Primager is, I would say, simpler because the instrument itself in the way you can control it is simpler. So as I said before, all bands are always observing and we're always reading them out. So there's always data coming there. But to define the observation, we need, or you will need to specify or explore which of the arrays is actually driving the observation constraint. And so typically in Primager, if you select the hyperspectral map, you need to indicate a wavelength in this map, which is going to be the pivotal wavelength you're interested in to estimate the performance. And in similarly, in polarimetric imaging, you need to specify one band, which is the band over which we will estimate the time the time required to achieve the observation. So typically, what I suggest to do here is to explore, because the time estimation is really fast. You know, it's a really simple equation to compute. And so what I suggest is really exploring which of the band is driving your observation requirement in terms of time. There's a survey area that is indicated because this is a mapping instrument. So if I'd say the main advice that I would bring here is that if you're intending to observe small area, typically of a few areas that fit within the telescope field of view, which is 20 by 40, I'd suggest using margin for the area because of the fact that the arrays are not superimposed on top of each other in the footprint; they are apart, and therefore the area that is mapped by all our arrays is smaller than the area that is covered by any given array because of their relative placement. So use margin in the survey area when you are observing small areas, but once you're in the square when you're in the fraction of a square of a degree, we're using the spacecraft, and I think then the relative positioning of the array doesn't matter anymore. So here the parameters are always the area that you want to map and the survey depth. You can toggle from watt per square meter to millijansky if you're more familiar with this unit. So these are the contacts person that you can call for in case you don't understand the behavior of the ETC bit. You can probably also contact me for Primager and Matt Bradford for Virus if there is a behavior of the ETC that you don't understand, or if you have questions that go beyond the ETC in understanding the requirements for your observation. And that's it.
A question.
Yeah.
What's the recommended strategy for ETC for extended source? Say I want to map using Virus to map a molecular cloud or something.
So for Virus, I cannot really respond. So I think this is really a question that probably need to wait for Matt. For Primager, I think we're going to implement rather soon the estimator for for extended sources, because we have, if you remember in the presentation I made, there are sensitivities estimated for extended sources, and these sensitivities are assuming this is the surface brightness of the source of interest, not the surface brightness of the source plus background. So at the moment, you can use these tables and the scaling relation that I've listed below to try and to go and estimate what would be the time needed for Primager map of a source of which you know the kind of ranges of surface brightnesses you want to identify. But I suspect that pretty soon we will implement that option in the Primager ETC, because it essentially, I mean, if you think about it, Primager resolves samples the point sources, so any source is an extended source in some ways. So it's just a question of mathematics equations to add this to the estimator. But for Virus, I recommend that we pass that question to Matt.
Thank you. I have another quick question, maybe not directly related to ETC. So in JWST, we face a lot of time some data rate issue. Is the PRIMA going to be limited by data rate as well?
I don't think so. I think I mean, intrinsically the kids are read at a very high frequency, but there's downsampling done on board, and the transmission system is geared to allow the transmission of well, we're dimensioning the whole system to avoid the data rate transmission.
Okay, makes sense.
So I will suggest, since we're close to the end of the hour, that we just keep this time as open questions in a large room. So any questions that folks have about any of the talks or topics not covered in the talks, please go ahead. So Gianni.
Yes, can I ask a question about the working groups? So if we are thinking about joining a working group, what should we imagine about like the workload? I mean, how many times do the working groups meet, and what kind of work is expected from the members? Could you explain a little bit more?
Yeah, so in the form we definitely make clear, you know, we're interested in folks who just want to attend occasionally, as well as folks who want to contribute at higher levels. We anticipate that the groups will probably meet about twice a month, and that most of the work right now, the initial task for the working groups is actually really going to be to help to coordinate and put together and support case submission for the geo book. And so since that due date is the end of May, so I anticipate sort of the next few months that will be sort of more intense. After that, I think it becomes a little more what the working groups want to make of it. For example, designing precursor science that can be done to sort of help pave the way for PRIMA science. So things with other observatories or other facilities, for example. But it's very much the level that you want to participate, and it's an opportunity. We're going to be hosting a lot of this on Slack, for example. You know, it's an opportunity to just stay plugged in at whatever level you want and be able to have access to updates.
Thank you.
Since folks are leaving, I do want to say before you go again, arigatou gozaimasu. Thank you so much for
Hold on, Elizabeth has a question.
Yes, no, I will answer the question as well. I just want to say again, thank you all so much. We appreciate your time, and we hope we were able to be helpful. Elizabeth, go ahead.
Thanks. It's just a really simple question, actually. Based on the distribution of scientific criteria in the first Go volume, is there any area that we would like to focus on, particularly for the second volume? Is there anything that would make the case for PRIMA stronger?
Yeah, so that's an excellent question. There are several areas that are very valuable to have more information on. One certainly is galactic cases. We're definitely interested. This is something also not covered in PI science, and so it's very valuable also just to make sure, I mean, it is covered in disks, but sort of galactic ISM mapping is not covered so much by the PI science. And so making sure we have a set of cases that make sure that the PI requirements are able able to provide the capabilities needed for that is very important. The other thing, and this is a little bit, I think virus cases particularly, right? So this is something, for example, if the mission had to be descoped and there was just virus available to do some of these cases, what is still possible to do in the both the high res but also the low res mode.
Maybe can I ask a question to the people who attend this telecon? Is there anything you wanted to hear and you didn't? Something we can add more information?
I think a little bit more information on PI science will be useful. For example, like one thing I didn't know before for the galactic one is the plans to get about 200 disks. So I think the number itself will be useful, right? So I totally understand us, we're not going to get a source list or something, but sort of like a general direction, it will be really useful for thinking about any, for example, GI science that we can tag along for the PI results.
Yes, that's an action we took. I mean, to give you all the information. But what I would like to say is that you don't need to prevent yourself from submitting anything. We'll manage to find out whether it's in conflict and whether it's a GEO case or maybe a GA case later on. So submit your proposal, and even if you think that might be in conflict right now, we'll find out exactly how this works. But yeah, you're right.
Yeah, and I think there are other ways you can look at it too. I think it's nice to see the scope of the PI case, but I mean, PI case is very limited to just 25% of the time. So I think one of the exciting things is also to be ambitious, right? Is there science that you think you can only do with 500 disks, or science that you can only do with 4 square degrees? We were really excited to have the all sky mapping case, right? An idea that yes, with the time available, that is one way that one could choose to use PRIMA, right? So I think making these cases now for what a large investment of time could pay back in terms of science, right, is a really nice way to really think about it and make the scientific argument for how that really large quantity of geotime could be used.
Yeah, I fully support what Elizabeth said. I mean, one of the purpose of the Geo book is to really demonstrate that PRIMA can be a community instrument, and so you could even have, we have to work within the constraint of justifying the mission with this 20%, 25% share, but you don't have that constraint, and if you have a great idea that requires 50% of the time, I mean, don't censor yourself, because it shows, for us it's important, it shows that yes, there are pretty spectacular things that can be done with PRIMA, and it strengthened the case of the mission. And as always, the fact that the community takes on a mission gives it strength in the selection process. So really think without limits.
Yeah, specifically this very wide sky survey, where maybe a sky or 1/4 of the sky will cover several topics, so that will need to have large community behind this type of proposal. So that will be very interesting to coordinate this type of things and to work globally as a team worldwide, probably with many expertises.
Yeah, but at this stage, we're not yet looking into how we would implement any of the cases. What we're interesting is that what are your ideas, and are they, and if they are feasible, they are valuable, because they show what PRIMA can deliver to the community. We need to pass the selection, and when we pass the selection, we will try to think about how, what kind of strategy we need to deploy to select, implement things. And PRIMA is supposed to have a 5-year lifetime, but there's not much consumable on the platform. So we could be optimistic.
That's related to politics as well.
All right, so we mentioned politics, so now we must end. Thank you so much again for joining. It was really quite lovely, and we will be posting the recording. We will also be posting slides, and I will also be doing my best to have a list of the questions and brief answers to them.
And don't forget, there is another session. A bit late for you, but it's possible. Thank you.